So the lesson plan for 10.8 is finally complete. You can see that those are the additional examples. You will be responsible for some of them I will do myself on the board. And what we're covering right now, the last concept that we're going to cover right now is the 5 properties of the natural logarithmic functions and the 3 laws of the natural logarithmic functions. Since the natural logarithmic functions are functions, their properties and their laws are going to be exactly the same. So let's review those properties one more time. So 5 properties. The 5 properties are, the first one is known as the one-to-one property. Log of n, or a base of e, is equal to log of n, or a base of e, if and only if n equals n. Second property, log of 1, or a base of e, is equal to 0 because e to the 0 is equal to 1. You should know, so this is longhand, but in most books you won't see the properties written like this. They'll just write natural log of n is equal to natural log of n. They will just write natural log of 1 is equal to 0. Let's continue. The third property will be log base e of e is equal to 1 because, remember this is the base, this is the exponent, because you need to raise e to the first power to get e. Like I said, other books will write this as natural log of e is equal to 1. The reasoning is exactly the same. Let's move on. Property number 4. Property number 4. Log base e of e raised to the k power is equal to k. Why is that so? Because e to the k is equal to e to the k. Or you need to raise e to the kth power to get e to the k. So because e to the k is equal to e to the k. Finally, property number 5. Oh, I forgot, I'm sorry about this. Let's write this in shorthand. I'm going to write it right here. This is natural log of e to the k is equal to k. Continue. The 5th property is e raised to the power of log base e of k is equal to k. I'm going to write the explanation. Log of k with a base of e, a logarithm is an exponent. This is the exponent to which you raise e to get k. When you raise e to the exponent to which you need to raise e to get k, you will get k. That is my explanation. And so property number 5, e raised to the power of natural log of k is equal to k. You can verify the last 2 properties using your graphing calculator. Okay, so the 5 properties have been covered. Let's now take a look at the 3 laws. I'm going to write the 3 laws in shorthand. So here they are. Natural log of n is equal to natural log of n plus natural log of n. This is the product law. We have natural log of n over n is equal to natural log of n minus natural log of n. This is the quotient. And finally, so law number 1, law number 2, law number 3. Natural log of n raised to the power of k is equal to k times the natural log of n. So there are your 3 laws and the 5 properties. We're going to quickly do an example where we use our laws and properties. Example number 1, it's asking us to simplify natural log of 1 over e squared, natural log of 1 over e squared. There are two ways to proceed. I'm just going to use the quotient law. This is natural log of 1 minus natural log of e squared. And now I'm going to use property number 2. So property number 2, natural log of 1 is equal to 0, or log of 1 over base of e is equal to 0, minus, and I'm going to also use property number 4, natural log of e to the k is equal to k. So natural log, and a mistake has been made, of course, 1 over e squared, 1 over e squared is actually e to the negative 2, not e to the positive 2. So anyways, I'm going to use the fourth property, natural log of e to the negative 2 is equal to, what am I doing? I apologize, it's not e to the negative 2, it's just e squared. So natural log of e squared is just 2, and this is negative 2. Yes, this is true, not needed for this problem. Let me go over it once more. First, quotient law, natural log of 1 minus natural log of e squared. Natural log of 1 is the exponent to which you raise e to get 1, so it's 0. And natural log of e squared is the exponent to which you raise e to get e squared, so it's 2. And finally, 0 minus 2 is negative 2. So I do apologize for all the confusion. That's part of life, making mistakes. I'm sorry about it, not on purpose. We're now going to move to b. For b, we need to condense that expression. That means you need to rewrite it as 1 logarithm. So we have 2 natural log of 5 plus natural log of 4 minus 3. So the first thing that we need is to do something about this 3. There's something wrong with it. The other ones have logs with the base of e, not 3. So the first thing that we do is we say, okay, I want 3 to be log base e of some number, and this should be equal to 3. This is our base, remember, this is our exponent. If we change from logarithmic to exponential, we have e raised to the third is equal to x. So finally, log base e of e cubed is equal to 3, or in other words, natural log of e cubed is equal to 3. So let's rewrite b, 2 natural log of 5 plus natural log of 4 minus natural log of e cubed. In previous lessons, we said the first thing that we're going to do is we're going to take care of the coefficients. I'm going to use the power law, the law that allows me to take a coefficient and rewrite it as an exponent. So this becomes natural log of 5 squared plus natural log of 4 minus natural log of e cubed. We're going to erase the board because we need more room. I'll let you think about the next few steps as I erase the board. Okay, very good. You see the plus? The plus is an indicator that I'm going to use the product law. So we have natural log of 5 squared times 4 minus natural log of 3. And finally, the minus tells us that we need the quotient law. So this is natural log of 25 times 4 over 3, or natural log of 100 over 3. That's the end of example 2.